Hello, my dear students. Today we will be discussing one new topic, and that is the variable mass system. Now, what is a variable mass system? So, suppose in any system, so this is your system, mass is getting added, or suppose the mass is getting ejected. So here the mass is getting added, and here the mass is ejected. So if either the mass is getting added to the system or the mass is ejecting from the system, then such system where the mass is changing with time is called a variable mass system. So here the mass is getting added, so you'll say that the rate of change of mass is positive. And here the mass is getting ejected, so you will say that the rate of change of mass is negative. So let us assume that the mass is added or ejected from a system at a rate alpha kg per second. So here you will write dm by dt is plus alpha, and here you will write dm by dt is minus alpha. Okay, and let the velocity of the added mass or the velocity of the ejected mass with respect to your system is given by v relative. Okay, so let the velocity of added mass with respect to the system is v relative. Then the force exerted by the system has magnitude which is equal to alpha multiplied by v relative. This force is called the thrust force and can be written as v relative dm by dt. Now, what is the direction of this thrust force? The direction of this thrust force is along the v relative if mass is added to the system. So if mass is added to the system, that means dm by dt is positive and the force is in the direction of v relative. Okay, and opposite to v relative when the mass is ejected from the system, because when the mass is ejected from the system, then dm by dt will be negative and the force will be minus of v relative alpha. So it will be in the direction opposite to v relative. So again I will write here F thrust is given by v relative dm by dt. So F thrust is equal to V relative dm by dt. Okay. Now again note V relative is again this I've already told you, but again I'll repeat. V relative is the velocity of added or ejected mass with respect to the system. So V relative is what? It is the velocity of the added or ejected mass with respect to the system. So here also I have written let the velocity of added mass with respect to the system is V relative. Okay. Now we will derive this relation. So let us suppose that at any time t the mass of your system is m. So let us draw the system. Let us draw this system. So this is at any time t, and this is, let us assign a different color. So at any time t the mass is m, and time t plus dt, the mass is m plus dm. Suppose the velocity is v. Suppose the velocity is v at time t, and the velocity becomes v plus dv at time t plus dt. Now for derivation, what we have done is we have assumed that the mass is ejecting. You can find also for if mass is added, but every time you will get the same answer. So we will derive only for one case when you will say that the mass is getting ejected. If the mass is getting ejected, dm has to be negative. The mass dm is ejected with relative velocity v relative, and here dm is negative. Okay, we will assume while deriving this, we will assume that the v relative is constant. So that means again I'll repeat what is v relative. So this mass which is getting ejected, this mass here which is getting ejected, so this mass here which is getting ejected, this mass is getting ejected with a relative speed. Relative speed means when you sit in the frame of this system, it appears to you that this ejected mass is moving with a velocity vrel. Okay, understood? So v relative is not the velocity of the ejected mass with respect to ground. So I will write it again for all of you. This v relative is not the velocity of ejected mass with respect to ground. But suppose you are asked to find velocity of ejected mass with respect to ground, then velocity of ejected mass with respect to ground is equal to the velocity of ejected mass with respect to the system plus the velocity of the system. So that means this is equal to vrel plus v system. Okay, so this v relative is not the velocity of the ejected mass with respect to ground. It is the velocity of ejected mass with respect to this observer which is sitting inside the system. Okay, so we assume one more thing that for deriving that we will assume is that v relative is constant. Okay, so now if there is no external force on this system, so we will, while deriving, we will take that there is no external force on the system, although the final formula that we will get is valid for any situation whether there is external force or not. So if there is no external force on the system, you will say that the momentum is conserved. That is, the momentum at this time has to be equal to the momentum at this time. Okay, so the momentum at this time has to be equal to the momentum at this time. So now again we have written here is what is written, velocity of the ejected mass with respect to the system is v relative. Okay, so the velocity of ejected mass with respect to ground is v relative plus v. Now see, in this diagram you will see that the initial momentum is mv. The initial momentum is mv, and the final momentum is m plus dm into v plus dv, right? Now see, your system contains total mass. That means the mass which was initially present and also the mass which is ejecting. So system contains the total mass. So initial momentum is m into v, but the final momentum here, look carefully, it is m plus dm into v plus dv. But this m plus dm is the mass of the remaining system, and minus dm is the mass of the ejected system. Why minus dm? Because dm is negative, because I have assumed that the mass is ejecting. So this is minus dm. Minus dm is the mass of the ejecting substance. Okay, so minus dm into, again see, listen carefully. Now when you are conserving momentum, you need the velocity of the ejected mass with respect to ground. So the velocity of this with respect to ground is how much? See, the velocity of ejected mass with respect to ground is v relative plus v. So you will write here minus dm into v relative plus v. Okay, in fact you can write minus dm into v relative plus v plus dv, but again dm into dv is very small, so you have to assume that dm multiplied by dv is very small. Okay, so we have neglected this. So we have neglected this, right? So now initial momentum is mv, has to be equal to the final momentum. So now by conservation of momentum, by conservation of momentum, you will get initial momentum is mv, the final momentum is mv plus dmv plus vdm plus dmdv, but dmdv is assumed to be dmdv, I already told you dmdv we will neglect, minus dmv relative minus dmv. You will see that dmv getting cancelled, mv getting cancelled. From this you will get mdv is equal to minus dmv relative. But now we have also assumed that v relative is a constant. So now what I have done is we have divided it both the sides with dt. So you will write m dv by dt is equal to minus dm by dt into v relative. Now listen to me carefully. Minus dm by dt is the rate of ejection of mass, that is alpha. So you will say that uh, F thrust, this m dv by dt is called F thrust. This m is not a constant mass, this is a variable mass. So this is called F thrust, and it is equal to minus dm by dt is alpha v relative. So we have derived the relation that thrust force thrust force thrust force is equal to alpha multiplied by v relative. Thrust force is equal to alpha multiplied by v relative. Okay, so again I will explain it again for the students who have still having doubt. Okay, so system the system that we take is the total mass. The total mass means which includes all the mass, that is the ejected mass also. Okay, so at this time, at t time, the mass is m, the velocity is v, so the initial momentum is mv. Now because if you have taken the total mass, there is no external force, so the momentum has to be conserved. Now after time t plus dt, the mass becomes m plus dm. Remember, this dm has to be negative. Okay, and the velocity becomes v plus dv, right? So now the velocity of the ejected mass, with respect to system is v relative. But what is the velocity of ejected mass with respect to ground? It is velocity relative plus the velocity of the system. You can also write this as v plus dv, but you will neglect this. Why? Because in the final situation the velocity is not v but v plus dv. Okay, but we will neglect this. Why? Because dm into dv is approximately 0. So the final momentum here you will get, the final momentum here that you will get is m plus dm into v plus dv. But this is the this is not the total mass. That this is all. This is the mass which is getting ejected is also inside your system. So you will say that this mass which is minus dm. Why minus dm? Because dm is negative. Why? Because it is ejecting, right? So minus dm into v relate the velocity of the ejected mass with respect to ground is v relative plus v. Now by conservation of momentum you will equate these two, and once you equate these two you will see that m dv is equal to minus dm v relative, since v relative is constant. So, and what we can do is we can divide it by dt. So m dv by dt is basically called the thrust force, and dm by dt magnitude is alpha. So the thrust force magnitude is equal to alpha v page. This formula thrust magnitude is v relative by dm by dt is valid whether mass is added or ejected. Although we have derived it for ejected mass, but this formula is valid for any situation. So whether it is mass is added or means ejected. Now the direction of force is along v relative. Again I am repeating the same thing that we have discussed in the first page. The direction of force is along v relative if mass is added, and opposite to v relative when mass is ejected. The direction of this thrust force is very important. The direction of this thrust force on the system is very important. So what again I will repeat, this direction is along the direction of v relative if the mass is added to the system, that is dm by dt is positive, and it is opposite to the direction of v relative when the mass is ejected from the system. Okay. Also this formula is valid even if there is an external force, although in this situation we derived the formula by using the no external force concept, but the formula for thrust force is valid even if there is an external force. Now what are the steps you must use to solve problems involving variable mass? So first step is make a list of forces acting on the main mass and then apply them on it. Then we will apply the additional force which is called the thrust force on the main mass, the magnitude of which is v relative dm by dt, and the direction is same as direction of v relative if mass is increasing and opposite to v relative if mass is decreasing. Then find net force on the body and apply F net is equal to m dv by dt. Then integrate with proper limits and you can find the velocity as a function of time. Now note, now in JEE you will see that most problems that they have asked in one dimension in variable mass is one dimensional. So you can replace this vector, symbol with a plus or a minus sign assigned to vector quantities. You know that vector which is towards right will be taken as positive and the vector which is towards left will be taken as negative. So now that we have understood what is the concept behind the addition of thrust force or application of thrust force, now we will solve problems regarding that. So suppose you have a flat car which has mass m naught and it starts moving towards right due to a constant force F. Now the sand is spilling on the flat car from a stationary hopper. So sand is spilling, but this is stationary. This is stationary. So now in this question you can see that the mass is getting added. The mass is getting added. So first of all we will write V relative. What is V relative? So let at any instant, see at t equal to 0 the velocity is 0. But at t equal to any time t, the mass of the system has become equal to m naught plus mu t, because mu is linearly increasing. Okay, because it is given that it is rate of loading is constant. So at t equal to 0 the mass was m naught, at t equal to any time t the mass will become m naught plus mu t. Okay, so this is the added mass that we have drawn here, and suppose at t equal to any time t the velocity that the cart has attained is v. So v relative is defined as, listen carefully, v relative is defined as velocity of the added mass, the velocity of the added mass with respect to the system. Now you can see that the added mass is coming from a stationary hopper. So that means in this direction the velocity of the added mass is 0. So v relative is equal to velocity of added mass is 0 minus velocity of system is v. So that means v relative is equal to minus v. Minus means the negative direction. So v relative, you can see in this diagram we have drawn that v relative is towards left, right? Okay, now what we will do is, first that now that we have found out v relative and mass is getting added, so you will say that the thrust force is given by v relative, that is minus v into dm by dt, that is mu. So F thrust is equal to minus mu v or v mu, right? Minus means the direction is, minus means the direction is, minus means what? The direction is opposite to, sorry, in the left direction or the negative direction. So now let us draw the FBD of the system. So you will see that this was the external force, and because mass is added, it is the thrust force is in the direction of v relative, which is towards left. So the thrust force is in this direction, and the value of the thrust force is mu v, and the mass of this at any instant is m naught plus mu t. So you will write the net equation as F minus mu v is equal to m naught plus mu t into dv by dt. Okay, now what they have asked us, they have asked us find the time dependence of velocity and the acceleration of the flat car in the loading process. So here this dv by dt is the acceleration of the flat car. Okay, now what you will do is you will write variable separate dv upon f minus mu v, dv upon f minus mu v is equal to dt upon m naught plus mu t. Now at t equal to 0, you know that the velocity is 0. At t equal to any time t, you need to find the velocity. From this, what you will do, you will integrate and you will say that minus 1 by mu ln f minus mu v, integrate it from 0 to v, is equal to 1 by mu ln m naught plus mu t, integrate it from 0 to t. Mu getting cancelled out, and you will get minus ln of f minus mu v divided by f. I have put the limits. First we have put, instead of v you will put v, and for the lower limit you will put 0, is equal to ln m naught plus mu t divided by m naught. So from this you will get, if you take this minus inside, you will get, and you will get f by f minus mu v is equal to m naught plus mu t upon m naught. So from this you will get, f m naught is equal to f m naught, or you can say like this, f minus mu v is equal to f m naught upon m naught plus mu t, right? So from this you will get f minus, f common, we will take m1 minus m naught upon m naught plus mu t is equal to mu v. So from this you will get the velocity as a function of time is f by mu into m naught plus mu t minus m naught divided by m naught plus mu t. So here m naught getting cancelled out, mu will get cancelled out. So you will get the velocity is ft upon m naught plus mu t. So you can see I have written the answer here. Velocity comes out to be ft upon m naught plus mu t. If you want to find the acceleration, what you can do is you can differentiate this again with respect to time. You will get the acceleration. I will not do that. I have already written the answer here. Okay, so now we will discuss the next question. In this question, it is given that a cart loaded with sand. So this is a cart which is loaded with sand and it is moving along a horizontal force. A constant horizontal force F is provided in the system. Okay, it is coinciding in the direction with the cart's velocity vector. In the process, the sand spills through a hole in the bottom. So there is a hole here at the bottom and the sand spills through it at a constant rate of mu kg per second. Then find the acceleration and the velocity of the cart at any moment t. If at the initial moment at t equal to 0, the cart with loaded sand has mass m naught and its velocity was equal to 0. So here you will see that first we have to find the thrust force, and if you remember the thrust force is equal to the magnitude is equal to V relative dm by dt. Now what is V relative? V relative is velocity of ejected mass with respect to the system. Now here let at any instant the cart has velocity v, then the ejected mass will also have velocity v. Why? Because you know that when an object is dropped from a moving object, this object acquires the velocity of the moving object. So here when the sand is spilling out, it is acquiring the same velocity as the velocity of the cart. So the ejected mass also has the same velocity, that is v. So therefore the relative velocity will become v minus v, and that is 0. There is no relative velocity, so that means the thrust force is 0. So there is no thrust force. Now if there is no thrust force, that means if you write the equation, now this mass of the system is changing, but there is no thrust force. So you will write F is equal to ma, that is m naught minus mu t multiplied by a. So from this you will get the acceleration is equal to f upon m naught minus mu t. So you have found out the acceleration. Okay, and then they have asked you the velocity as a function of time, and the initial moment t equal to 0, the velocity of the cart was 0. So acceleration we have found out. Now we need to find velocity. Now it's just kinematics. So you can say that acceleration is dv by dt is equal to f upon m naught minus mu t. So dv is equal to f dt upon m naught minus mu t. So if you integrate, you will get at t equal to 0, the velocity is 0. At t equal to any time t, we need to find the velocity. So you will write v minus 0 is equal to f. This is what? Minus 1 by mu ln m naught minus mu t. Integrate it from 0 to t. From this you will get V is equal to F minus F by mu ln m naught minus mu t divided by m naught, or you can say V is equal to F by mu ln m naught upon m naught minus mu t. What we have done here, we have just proved the limits. First upper limit, then lower limit, and then log a minus log b is log a by b. So you have got the function of velocity. So they have asked you the function of acceleration and velocity. We have found it. Now we will discuss the next problem. A uniform chain of mass m and length l hangs on a thread and touches the surface of a table by its lower end. Find the force exerted by the table on the chain when half of its length has fallen on the table. The fallen part does not form heap. Okay, so it is given that this part is falling, and as this is falling, it does not form a heap. Okay, so at any instant, at any instant we assume that the length of the chain on the ground is x, so the length of the chain still in air becomes L minus x. Okay, now what will be the velocity of added mass? So suppose this is your system, and the mass is continuously getting added to the system. Now what is the velocity of added mass? So you know that when so if x length of this has fallen, the chain has attained a velocity root 2 gx. So the velocity of added mass to this system is root 2 gx. So of the added mass is root 2 gx, the velocity of added mass, minus velocity of the system is 0. So that will be equal to root 2 gx, and this direction will be downwards. So the thrust force is given by V relative dm by dt. So that will be equal to root 2 gx dm by dt. Now we need to find dm by dt. So at any instant this length is x. So what is the mass at this instant? So mass at this instant is added mass is m by L into x. Now rate at which mass is added, dm by dt will be equal to m by L, this is a constant, x is changing, dx by dt, but rate at which x is changing is basically what? Velocity. So m by L into velocity, so that is equal to m by L into root 2 gx, because this is the velocity of the added mass. Okay, so the thrust force will come out to be, therefore the thrust force will come out to be, the magnitude of the thrust force will come out to be root 2 gx multiplied by m by L into root 2 gx. So that is equal to m by L into 2 gx, and the direction of the thrust force will be in the direction of relative velocity. The relative velocity is downwards, so the direction of the thrust force will also be downward. Now the thrust force, we have got thrust force is m by L multiplied by 2 gx. Now if you draw the FBD of the system, if you draw the FBD of this system, what will you get? So if you draw the FBD of this system, the mass here is m by L into x. So there will be gravity force m by L into x into g. There will be the normal reaction, and there will be the thrust force. And what is the value of the thrust force? That will be m by L into 2 gx. So the net normal reaction for any x will be equal to 3m by L gx. Now in the question they have asked when x is L by 2, that is half of the length has fallen. In that case, so if half of the length, if half of the length has fallen, in that case you will say that n is equal to 3m by L g into L by 2, that is 3mg by 2. This is the normal reaction when half of the length has fallen. So again see what they have asked. Find the force exerted by the table on the chain, that is the normal reaction when half of the length has fallen on the table. So when half of the length has fallen on the table, just put x is equal to L by 2. So we have found out first the normal reaction as a function of x in general. Then at the end we have put value of x as L by 2. Okay, now let us take the next question. In this question it is given that if the chain is lowered at a constant velocity v is equal to 1.2 meter per second, determine the normal reaction exerted on the floor as a function of time. The chain has a total mass of 80 kg and the total length of the chain is 6. So let at any instant the chain has fallen by a distance x. Okay, so again you will say that the relative velocity this time is 1.2, same as before. This is the system and the mass is continuously getting added to the system. So this is the system and mass is continuously getting added to the system. So the relative velocity is 1.2. Here it is a constant. So if you want to find the thrust force, you will see that again the mass added to the system, mass added to the system is m by L multiplied by x. So the rate at which mass is added to the system is m by L dx by dt, that is m by L into v. So that is v relative. So the thrust force magnitude will be equal to v relative is v into dm by dt is m by L into v. So that is m by L multiplied by v square, and this thrust force is again downwards because mass is added to the system. The direction of relative velocity is downwards, so the thrust force is also downwards. Okay, so now you have got the thrust force. Again what you will do is you will uh, draw the FBD of the system. So this is the system, the length is x, the gravity force is m by L multiplied by x into g, the normal force is this, and there is a thrust force, and this thrust force is m by L multiplied by v square. So therefore the net normal reaction at any instant will be m by L v square plus m by L x multiplied by g. So now you put the values of m, L and v, you will get the normal reaction. Okay, now we will discuss the next question. This is the question 1.184 from Irodov. So it is given that a chain AB, this is the total chain AB, of length L, the total length is L, is located in a smooth horizontal tube. So this is the smooth horizontal tube, so that its fraction of length L, so this is the complete tube, this one, and the fraction of length, that is H, hangs freely, this is hangs freely and touches the surface of the table at B. At a certain moment, the end A of the chain is set free. Then with what velocity will this end of the chain slip out of the tube? When this horizontal length becomes 0, what is the velocity of this point? So when this point reaches this point, when A reaches here, then you are asked what is the velocity of A. So now let at any instant the part that is horizontal, the part of the chain that is horizontal is x. Okay, then you will see that, so if this is your system, you will see that the mass is getting ejected from the system. Mass is getting ejected from the system. Now, what is the relative velocity of the ejected mass with respect to the system? Because the system is moving with suppose velocity v and the mass is getting ejected with the same rate, so that's why mass is ejecting, means the ejecting mass is also has the same velocity. Therefore, you will say that the relative velocity is 0. Now, since the relative velocity is 0, therefore there is no thrust force. There is no thrust force. Now at any instant when this is x, you know that this vertical length will remain constant. So this vertical length of the chain will apply the gravitational force, gravitational pull on this part. Okay, so the mass of this part, the mass of vertical part, the mass of vertical part of the chain is equal to m by L multiplied by h. So the force due to gravity, this part will not exert the force which has come out. Why? Because it is balanced by the normal reaction. This part is not exerting the gravitational force. Only this part that is hanging, that is a constant length, is exerting the force. So force due to gravity will be equal to m by L h multiplied by g. Now due to this force of gravity, this system will accelerate. Now listen to me carefully. This force of gravity is actually accelerating this entire system. So you will say that m by L h g must be equal to m by L into x plus h into a, because this portion is also accelerating. Okay, yes, this system, in this system, this entire system mass is getting ejected, but still there is no thrust force because the relative velocity is 0. Okay, so m by L into h into g, this is the net force, there is only gravitational force here, there is no friction, is equal to m by L multiplied by the total mass is m by L multiplied by x plus h into a. So this is net force is equal to mass into acceleration. When you cancel this, you will get a is equal to gh upon x plus h. Now once you've got the relation of a, now a is what? A is rate of change of velocity. A can also be written as v dv by dx. But see, right side is a positive term, so left side has to be a positive term. Now x is decreasing, right? So you will say that a is equal to minus v dv by dx. Why? Because the x is decreasing, so if x is decreasing, dv by dx is negative. Velocity is increasing, with means as x decreases velocity increases, so that means dv by dx is negative. So to make this system positive, this negative has to be introduced. All right, so minus v dv by dx is equal to gh upon x plus h. So here separate the variables and integrate. So you will say minus v dv is equal to gh into dx upon x plus h. From this you will get minus integration v dv is equal to gh integration dx upon x plus h. Now let us look at the limits. See, the total length is L. So this horizontal length is L minus h. So when the horizontal length, because x is the horizontal length, so when the horizontal length is L minus h, the velocity is 0. When the horizontal length is 0, why? Because we are asked what is the velocity of point A when it reaches here, right? So when the horizontal length becomes 0, we need to find the velocity. So from here you will get minus v square by 2 is equal to gh ln x plus h, integrate it from L minus h to 0. So from this you will get v square is equal to minus 2gh ln h minus ln L minus h plus h. Just first put x equal to 0, then put x equal to L minus h. So from this you will get v square is equal to minus 2gh ln h by L. Now if you take this minus inside, you will get v is equal to under root 2gh ln L by h. Let us start with rocket propulsion. So what is rocket propulsion? You know that when a rocket is fired, what happens? There is a fuel here. This fuel is burned, and it ejects gases, and this due to the ejection of this mass, a thrust force is applied on this rocket, due to which it moves upwards, right? So let m naught be the mass of the rocket. Let m naught be the mass of the rocket at time t equal to 0, and m is its mass at any time t. So at any time t, m is its mass, okay, and v is the velocity at that instant. Let the initial velocity be u. Normally the initial velocity will be given as 0, but we are finding it in general. So let us take the velocity at t equal to 0 be u. Okay, let the exhaust velocity, now exhaust velocity, this exhaust velocity means the velocity of the ejecting gases, is v relative. So remember one thing, whenever they are giving you exhaust velocity, whenever they are giving you, that means they are giving you the relative velocity. The exhaust velocity is always calculated relative to the rocket. Okay, the exhaust velocity is always calculated relative to the rocket. So let dm by dt be the mass of the ejected gas per unit time, and v relative is the velocity of the exhaust gas with respect to rocket. I have again written it. Note, exhaust velocity means the velocity of the ejected gas with respect to rocket. We will assume that this v relative and the dm by dt is constant. This dm by dt will also be referred as mu. Like every time we are referring dm by dt as mu. Okay. So now what will be the thrust force? You know that the magnitude of thrust force is equal to dm by dt multiplied by v relative. Now v relative here, see, what is the direction of v relative? What is the direction of v relative? So v relative, listen carefully everybody, see, v relative is velocity of exhaust gas with respect to rocket. Now with respect to rocket, the velocity of the exhaust gas is downwards, so v relative is downwards. Now since mass is getting ejected, I have already told you, when mass gets ejected, in that case the thrust force is opposite to the relative velocity. So if the relative velocity is downwards, the thrust force will be is upwards, the gravity force is downwards. So the thrust force is dm by dt magnitude v relative, that is mu v relative, right? And the gravity force is downward, so you will write ft minus mg is equal to m dv by dt. That means mu v relative minus mg is equal to m dv by dt. But mu relative, mu can be written as minus dm by dt. Why mu can be written as minus dm by dt? Because the mass is getting ejected. Mu is a positive number. If mass is getting ejected, dm by dt is negative. This negative and this negative combines to form positive. So you will say this is equal to minus dm by dt v relative is constant, minus mg is equal to m dv by dt. So now you will variable separate and integrate it like this. dv is equal to dm by m v relative minus g dt, right? Just dt, you have cross multiplied with this side with dt and this side with m. Okay, so from here you will get, if you integrate this, you will get at t equal to 0 the mass is m naught and the velocity is u. At t equal to any time t the mass is m and the velocity is v. So you will say v minus u is equal to, from here you will get minus gt, g is a constant, integration dt is t, plus from here you will get the v relative is constant and dm by m is ln m. So from here you will get v relative ln m naught by m. So the final relation will come out to be v is equal to u minus gt plus v relative ln m naught by m. So this is the final velocity for rocket propulsion. This is the velocity that the rocket will achieve in time t. Okay. If gravity is ignored, then this term becomes 0. And if the initial velocity is also 0, then the velocity becomes v relative ln m naught by m. VR here is v relative. Now let us do one question. A rocket with an initial mass of 1000 kg. So in this question it is given to you that m naught is equal to 1000 kg is launched vertically upwards from rest under gravity. The rocket burns fuel at a rate of 10 kg per second. That means mu is given as 10 kg per second. The burnt matter is ejected vertically downwards with a speed of 2000 meter per second relative to the rocket. So the relative velocity is given to you as 2000 meter per second. If the burning stops after 1 minute, then find the maximum velocity of the rocket. So if the burning stops after 1 minute, that means after 1 minute, so it is given that after 1 minute, the thrust force becomes 0 and then the velocity becomes maximum. The velocity becomes maximum. So basically you need to find velocity at t equal to 1 second, 1 minute. So we need to find velocity at t is equal to 1 minute. So we can directly use the relation that we have got just now. V is equal to u minus gt plus v relative ln m naught by m. So you will write v is equal to u, that is what is given. See here the initial velocity is 0 minus gt, gravity is there, so 10 into t, t is how much, 60, 1 minute is 60 seconds, plus v relative is given as 2000 meter per second multiplied by ln, initial mass is 1000 kg, divided by final mass is m, where m is what, m naught minus mu t, that is 1000 minus mu is how much, 10 into t is how much, 1 minute, that is 60 seconds. So that is equal to 1000 minus 600, that is 400. So this becomes 400. So from this you will get the velocity after 1 minute, that is the maximum velocity, will be 2000 ln 5 by 2 minus 600 meter per second. Okay, we will not calculate this further. Let us discuss the next question now. Find the mass of the rocket as a function of time if it moves with a constant acceleration. So in this question it is given that the acceleration of the rocket is constant. Acceleration of the rocket is constant and there is no external force. There is no external force. So these are the information given in this question. And also the relative exhaust velocity, the relative velocity is the relative velocity of the ejected fuel is equal to u, and the initial mass of the rocket, the initial mass of the rocket is m naught. So we need to find the mass of the rocket as a function of time. So what we will do here, see, you know that there is only thrust force acting here. There is no gravity. We have to assume there is no external force. So there is only thrust force acting. So the thrust force will be equal to mu means dm by dt, that is minus dm by dt multiplied by u. All right. Now this is, according to question, this is equal to m into a. Now in this question it is given that a is constant. So you can say that minus dm by m is equal to a by u dt. A and u are constants. At t equal to 0, it is given that m mass is m naught. At t equal to any time t, the mass is m. So you will say that in this case, you will say that ln m naught by m is equal to a t by u. So which implies m naught is equal to m e की power a t by u, or m is equal to m naught e की power minus a t by u. So this is the mass of the rocket as a function of time. Okay, in this question it is given that we have two blocks A and B of mass m1 and m2 respectively. The mass m1 is a constant but mass m2 is a variable. Here sand is getting ejected by some internal mechanism with a relative velocity v downwards. So initial mass is m naught and the sand is getting ejected with a velocity mu kg per second, and the relative velocity of the ejection of sand is b in the downward is v in the downward direction. Assuming m1 is greater than m2, that means m1 is greater than the initial mass of m2, that is m naught, find the acceleration of a. Now let us draw this figure here. So let us because it is given that the pulley is ideal, the system is ideal, so let the acceleration of this be a downwards and this will be a upwards. Why? Because m1 is more, so we are assuming that the acceleration is a downwards and this is a upwards, and uh, the tension in the string is T. So if you draw the FBD of M1, if you draw the FBD of M1, so there will be a force M1G, there will be tension T, and you will write this equation as M1G minus T is equal to M1A. If you draw the FBD of M2, if you draw the FBD of if you draw the FBD of M2, now you will see that there will also be one thrust force. Now the thrust force magnitude will be mu multiplied by V relative, that is mu V, and the direction will be opposite to the relative velocity. Why? Because here mass is ejecting. Mass is ejecting, that means the velocity means the thrust force is opposite to the relative velocity. It is given that the relative velocity is downwards, therefore the thrust force will be upwards. So there will be a thrust force upwards, there will be force of gravity downwards, and there will be tension upwards, and this is accelerating upwards with a. So you will write T plus thrust force, that is mu v, minus m2g is equal to m2a. Now this is equation 1, this is equation 2. If you add this to equation, you will see that the tension getting cancelled out and you will get m1 minus m2 multiplied by g, m1 minus m2 multiplied by g plus mu v is equal to m1 plus m2 multiplied by a. From here you will get a is From here you will get A is equal to m1 minus m2 into G plus mu V divided by m1 plus m2. Okay.